You ever just stop and listen to your house? You know, that gentle hum coming from the fridge, or the whir of a fan kicking on, or that rumble when the washing machine starts its cycle? I mean, that's the sound of work getting done, right? But what's actually doing all that work? Well, it turns out there's this one single, really ingenious device that's at the heart of pretty much all of it. I mean, just think about it for a second. These are totally different machines, right? One's job is to keep your food cold, another one just moves air around, and another tumbles your clothes. But here's the thing. They all share this secret, this common ancestor that's making them all spin and pump and churn. And that secret is the single-phase induction motor. Okay, I know, it doesn't exactly sound glamorous, does it? But trust me, this little marvel of engineering is the unsung hero of our modern world. It's the invisible workhorse hiding inside almost everything you own. And no, I'm not exaggerating one bit. This thing isn't just common, it is the most frequently used motor on the entire planet. Seriously, the scale is just staggering. And there's a really, really good reason for that. All right, so why this motor? Why is it the most common one in the world? Well, it all boils down to two things. It's super reliable and it's cheap. The real secret is its design. It's incredibly simple and tough. It's built around this thing called a squirrel cage rotor, which sounds kind of funny, but the key is it has no complex parts that can wear out. It's just elegant, practical engineering at its best. And because it's so simple, it's also incredibly durable and ridiculously cheap to make millions of them. I mean, if you're a company making tons of washing machines or refrigerators, what do you want? You need a motor that just works every single time and doesn't cost a fortune. Well, this is that motor. But, and this is the crazy part, for all its success, this motor has a massive, almost comical flaw, a huge problem right at the heart of its design. By itself, it can't start at all. It's like having a car with a super powerful engine, but no starter motor to get it going. Okay, so to understand why, we need to talk about what a motor needs to work in the first place. See, all electric motors run on something called a rotating magnetic field. Just picture an invisible force that's spinning, kind of like an invisible hand grabbing a compass needle and just spinning it around and around. That's the kind of continuous rotating force you need to get the motor's rotor to spin along with it. Now, big industrial motors, they get a special kind of power called three-phase power. And that stuff naturally creates that perfect, smooth, rotating field. Easy peasy. But our homes, we have single-phase power. And that creates a magnetic field that doesn't rotate. It just pulses. It just goes push, pull, back and forth. All it does is make the rotor kind of shudder and vibrate in place, but it never gives it that crucial spin to actually get going. So there's the big paradox, right? If the most popular motor on the entire planet can't even start by itself, then how is your fridge humming along right now? How is anything working? Well, the answer is some absolutely brilliant engineering tricks. See, engineers can't change the power coming out of your wall outlet, so they had to get really clever. They came up with a whole bunch of tricks, you could say, to give the motor that little nudge it needs to get started. Okay, so the first and most common trick is called the split phase design. What they do is add a second helper coil of wire. They call it the auxiliary winding. Now, they design this helper winding to be just a little bit different electrically from the main one. And what that does is it creates a second magnetic field that's kind of out of sync with the first one. When you put those two pulsing fields together, they combine to simulate a weak rotating field, and that's just enough to give the rotor that little push it needs to finally start spinning. Now, that gentle push is perfectly fine for something simple, like a small fan. But what about something heavy-duty? Think about a refrigerator compressor that has to start pushing against really high pressure right from a dead stop. That needs a lot more muscle. And for that, we bring in another little component, the capacitor. The easiest way to think of a capacitor is like a tiny, super fast battery. It sucks up a charge of electricity, holds it, and then, bam, releases it all in one powerful, sudden burst. So what they do is add this capacitor to that helper winding. And when the motor starts, that capacitor gives it a massive electrical kick. This creates a way stronger starting force, what engineers call torque, that lets the motor power through really heavy loads. Then, once the motor gets up to about 75% of its full speed, a little switch clicks open, disconnects the capacitor, and the motor just keeps on running on its own. So, you see, it's all about picking the right tool for the job, Engineers choose the starting method that fits the application. You're not going to waste money on a powerful capacitor for a simple desk fan, and there's no way a basic split-phase motor could ever get a big air conditioner compressor going.
It really breaks down like this. You've got your basic split-phase motor, which has low starting power, perfect for things like fans or office equipment. Then you've got the capacitor start motor, which delivers that high power punch for heavy-duty jobs like compressors and refrigerators. And for stuff that needs almost zero starting force, like a tiny fan in a hairdryer or in a toy, there's an even simpler and cheaper design called a shaded pole motor.
So when you step back and look at the whole story, it's pretty amazing. We've watched how this modern electric workhorse went from being a fundamentally flawed design to an absolutely essential piece of technology. It all started with a motor that was, almost perfect, super simple, tough as nails, and cheap to make. But it had that one giant fatal flaw. It couldn't get itself going. And that single problem was solved, not with just one fix, but with a whole toolkit of clever engineering tricks. You've got the split-phase trick for a gentle start, the capacitor kick for the heavy loads, and the super simple shaded pole method for small devices. Each one is perfectly tailored for a specific job. And it was that ingenuity, that clever problem-solving, that transformed a flawed design into the single most important motor in the world. It really is the quiet, reliable workhorse that powers our modern lives, completely behind the scenes. So the next time you hear your home kinda hum to life, maybe the fridge kicks on, what hidden ingenuity are you gonna think of? Because that's not just the sound of a machine working. That's the sound of a really tricky problem being brilliantly solved over and over all around you.